Today's objective is polygons and quadrilaterals. Poly means many, and the suffix gon means angles. So a polygon is a many-angled figure. Quad, you know, means four, and lateral means side or sides. So this is a four-sided figure. I'm going to cross that off. I like it to just say side. A polygon is a closed figure made of line segments that do not cross. These are examples of polygons. And remember, the tick marks, these lines going through, tell you that those sides are congruent. Okay, so these we're going to talk about in a minute. These would not be polygons because a circle is not a line segment, and that's not a closed figure. That one crosses, and that's not a closed figure. Regular polygons have congruent, remember that's how you say equal or the same in geometry, congruent angle measures and side lengths. So for example, a square, this would be a regular quadrilateral, an equilateral triangle, that's a regular polygon, and then other regular polygons that you see like octagons, like stop signs and things. Concave, you notice we have a lot of vocabulary right now. Concave means the sides go in like a cave. So like this one, see how that side goes in? Or this one? You can go outside of the shape when you are connecting 2 points. So if I'm going to connect these 2 points, I go outside the shape. Okay, so that's a concave polygon. Convex, the sides don't go in. So any place I draw 2 points inside, it would stay inside the figure when I connected them. All quadrilaterals have 360 degree interior measures, since they can all be cut into 2 triangles. And remember from our triangles video, every triangle has 180 degrees. So that's one. You can cut this way, and you can cut it other ways too. Let's cut this one like that. This one diagonally this way, and how about if we cut this one this way? And that's all the triangles we can cut it into. So since there's 2 triangles and each triangle is 180 degrees, 2 times 180 is 360. Now we're going to classify or name our quadrilaterals. The first one I have listed is a trapezoid. Trapezoids have 1 pair, remember that means two, but it's 1 pair of parallel, and remember that's the symbol for parallel, sides. Okay, so when you see these little arrowheads on sides that are across from each other, that means they're parallel. Okay, so in this one and this one, the top and bottom are parallel. This one, the top and bottom are parallel. This is an isosceles trapezoid. See the little tick marks on the side, meaning that it's the same length? Isosceles trapezoid has congruent side lengths. Okay, the lengths on the side. I don't mean all the sides, just the ones on the side. Okay, number 2, a parallelogram has 2 pairs of parallel sides. And the opposite sides also have the same measure in a parallelogram. And all the rest. A rectangle has 2 pairs of parallel sides and 4 90-degree angles. So here are our 4 90-degree angles. I did not put in all of the parallel line symbols because it would be too crowded, but these opposite sides are congruent and those opposite sides are congruent. So technically it's a parallelogram also. Every rectangle is also a parallelogram, but we name them by their most specific name. All right, a square has 2 pairs of parallel sides and 4 90-degree angles, and all sides are congruent. So here we had 2 tick marks on these 2, but 1 tick mark on those 2, saying these are the same, and the left and right are the same, but they're not all 4 the same. Whereas in a square, there's only 1 tick mark on each side, saying they're all the same. So a square is also a rectangle, technically, which means it's also a parallelogram. All right, a rhombus has 2 pairs of parallel sides and all sides are congruent. So our sides are parallel and they're congruent, which means this is a parallelogram, But even though the sides are congruent, it's not a square because it doesn't have the 490-degree angles. Let's do a little problem. Since you know that all quadrilaterals have 360-degree interior measures, you can find the missing angle measures if I give you some information. So this is a quadrilateral. It's none of those ones that I've named. It just has 4 sides. This top angle is 68 degrees. This indicator, remember, is our 90 degrees. It shows that our 2 lines are perpendicular, so that's a 90-degree angle. This angle is 2x plus 1 degrees, and this angle is just x degrees. So we just add up the interior numbers that were given. 68 plus 90, that's our 90, plus 2x plus 1, that means they go together, plus x equals 360. Now we combine like terms. 68 and 90 is 159. Oops, I'm sorry. 68 plus 90 plus 1 is 159. 2x plus x is 3x. So 3x plus 159 equals 360. We want to isolate our variables, subtract 159 from both sides of the equation. We get 3x equals 60 take away 59 is 1. 300 take away 100 is 2. So 3x equals 201. Divide both sides by 3. And now let's divide. 3 goes into 20 how many times? Hopefully you said 6 because it's 18. And then how many left over? 21. So 3 goes into 21 7 times. So x, this angle is 67 degrees. Now we need to find out what the 2x plus 1 is. I wrote this problem over here, so I'm not going to have room, so I'll do it over here. So I'll say 2 times 67 plus 1. Well, 2 times 7 is 14. 2 times 60 is 120. So 120 plus 14 is 134, plus 1, 135 degrees. Okay? So I should say 67 degrees because that's our answer. Now we need to check. We need to add them all up, and it must equal 360 degrees. So here we go. 7 plus 8 is 15, plus 5 is 20. Remember, when you're adding, you can do it in the order that works best for you, and I always try to make 10s or 20s. Okay, so now I'm going to say, can't make any 10s or 20s. So 2 plus 6 is 8. 8 and 9 is 17, plus 3 is 20, plus 6 is 26. Carry the 2, 360. So it's 360 degrees, so I know I'm good. That's it.